Part 2, we're going to review some just triangle applications. And for the first one, Rosencrantz and Guildenstern are trying to get away from England and have decided to travel in different directions. Rosencrantz travels east, so they're starting together, and it seems like Rosencrantz is traveling east at 15 miles per hour, while Guildenstern travels south, straight south, at 10 miles per hour. After 3 hours, how far apart are they? So that we want to know what this distance is. Now, because we're going straight east and straight south, we know that's going to be a right triangle. So we're looking for the hypotenuse. Okay, so might as well call that C. So what we need to do is find out how far each one of these how far they each traveled. Rosencrantz is traveling at 15 miles per hour, so in 3 hours he travels a total of 45 miles. So that's this distance. Guildenstern is traveling at 10 miles per hour. So after 3 hours, he's traveled 30 miles. And there's Guildenstern's distance. So, of course, because it's just a simple right triangle problem right here, we're going to look for the hypotenuse. We're going to use our Pythagorean theorem. A squared plus b squared equals the hypotenuse squared. Sometimes I like to write it that way. I'm crazy. So it doesn't matter which one's A or B, since they're both legs. So we would go 45 squared plus 30 squared equals c squared. And then we'll just use our calculator. Clear it out. 45 squared plus 30 squared. And we take the square root of that. 2925. And that gives us that they are now about 54.08 miles apart after 3 hours. Right. Part C, number 2, I'm sorry, it says, how long are the legs of an isosceles triangle if the base is 16 inches and the legs meet at an angle of 36 degrees? So I'm going to draw an isosceles triangle. Remember, in an isosceles triangle, we're told that the two legs are the same. Now we're told that the base is 16 inches long and that the top angle is 36 degrees. Now you may be thinking, man, I don't have enough information. I got a side and an angle. That's not enough information to get the legs. But remember, because these two angles are the sides are the same, their opposite angles must be the same. So to get the base angles of an isosceles triangle, we can take 180 minus 36 and then just divide that by 2. So if I take 180 minus 36 and divide that by 2, we get 72 degrees. So each of these is 72 degrees. And now if you notice, now we have angle, side, angle. So because I have angle, side, angle, I can use law of sines in this case. Or if you want to, angle, angle, side might be the better reason. Okay, angle, angle, side. Sorry about that. So using law of sines, I can now find this length. So I'll call this A, B, C. Doesn't matter. So I want to find A. So if I wanted to find A here, I'm going to take the sine of 72 over A. What I'm trying to find equals the sine of 36, something I already know, over B, little b, which is 16. Cross multiply, A sine of 36, and what is 16 times the sine of 72? And that's going to give us 15.22. And that is inches. Not done yet. And then I, of course, have to take that 15.22 and divide that by the sine of 36. And we're going to get A equals 25.89 inches. And that's both of the legs. So both legs, because they have to be equal 25.89 inches. And there's our answer. All right. And our last example In a rush to hurry delivering presents, Santa just drops gifts through the chimney rather than going down himself. Coming upon Mr. Warnow's house, he's always good, he measures the angle of depression to be about 46 degrees. And so here's Santa, he's traveling, blah, blah, there's his little reindeer. He's traveling in a straight path. Well, Mr. Warnow's house, which is down here, is at an angle of depression of 46 degrees. No. And he says that the line of sight distance, so that's the actual distance right here, is 400 meters. Through a complicated algorithm, Santa knows he must drop the present when the angle of depression is 82 degrees. So he has to travel some point over here where the angle of depression is now 82 degrees. How much further must he travel in order to drop the gift through the chimney? So what we wind up having, and I'll draw this in red, is this triangle right here. And what we're asked to find is how far he has to travel. So if I call this A, this point B, and the house C, we're looking to find little c right here. So let's see what we're given here. We're given an angle and a side of my triangle and nothing else. So we have to do a little bit of math. I'm going to go ahead and find this angle right here. So to get this angle, it's easy. We can get 180 minus 82. And using your calculator, 180 minus 82, we get 98 degrees. Which is kind of good for us because I have an angle, and I have an opposite side. So we have angle, angle, side, therefore it's our law of sines. We have our law of sines right here. And I want to find C. Whoops, the problem is for C, I need an angle. Man, I need angle C. So to use law of sines, I need angle C. So how do I calculate that? Yeah, it's just 180 minus the 98 that we found minus the 46. And if we use the calculator here, take 180 minus the 98 minus the 46, we get 36 degrees. So here's 36. So now we can use our law of sines. I'm going to take the sine of 36 over little c equal to, I know this angle and I know B and its opposite side, so I take the sine of B, which is 98 over the 400. Cross multiply, C times the sine of 98 equals, and I'm just going to multiply here together on my trusty dusty calculator. Not dusty really, I use it all the time. 400 times the sine of 36, and that gives me 235.11. 235.11. And now I have to find C. So I take that 235.11, divide that by the sine of 98. And I hit enter, and we get about 237.42. So it's 237.42 meters is how far Santa will have to travel in order to drop off my gifts. I hope it's a Ferrari. Take a look at these again if you need to. We're going to practice a couple more of these, and don't forget tomorrow we do have a quiz.